Okay, here's some gas law questions. It says, I have 5 liters of ammonia gas, needs to be stored. They need to store it at 20 Celsius and 17 atmospheres. How many moles of ammonia will be in the tank? Okay, and then how many grams is this? So, yeah, okay, so I'm going to use this formula, PV equals nRT, because they gave me a volume right there, and they gave me a temperature right there, which I'll need to convert. Let's change that temperature. So it's 20 degrees Celsius plus 273.15 would be 293.15 Kelvin. And they give me a pressure. Well, the pressure is 17 atmospheres. Because I'm using this, I need to change that to kilopascals. So 1 atmosphere is the same as 101.325 kilopascals. So I'll get a pressure for that. And then, so I'll know the pressure so I can find moles. So moles are going to be equal to PV over RT. The pressure, let me figure that out. Okay, that comes out to 1722.525. So pressure, 1722.525 kilopascals times the volume is 5 liters divided by R, 8.314 kilopascal liters per Kelvin mole. And the temperature is 293.15 Kelvin. Kelvins cancel, kilopascals, liters cancel, left with moles. I'll do the calculation. So that comes out to 3.5337 moles. Rounding it to 3 sig figs would be 3.53 moles. Now to convert that to grams, moles are equal to mass over molar mass. If I'm looking for mass, that's equal to moles times molar mass. The moles we just figured out are 3.53 moles, and I have to multiply by the molar mass of ammonia. Ammonia is NH3, so nitrogen's 14.01, 3 hydrogens are 303, so I need to multiply that by 17.04 when you add those together. Okay, so this number times 17.04. So it comes out to 60.215, rounded to 3 sig figs, 60.2 grams. Okay, next question. What pressure is exerted by 54 grams of xenon contained in a 10-liter flask? Okay, again, this will be the ideal gas law. Because, like if you do P1, V1, T1, N1, P2, V2, T2, N2, they give me some grams, so from that I can find moles. They give me a volume, 10 liters. They give me a temperature, again 273.15. And so I know I can figure that out, and I'm looking for pressure. But they're not changing any of those. So I'm not going to use any of those other gas laws. I'll be using PV equals nRT. And I'm looking for pressure. So pressure is nRT divided by V. So the number of moles, I'll have to figure that out. Moles are mass over molar mass. Mass is 54.0 grams. The molar mass of xenon, it's right up here. 131.29. 131.29 grams per mole. That comes out to 0.411, etc. moles. So 0.411 moles times universal gas constant, kilopascal liters per Kelvin mole, times the temperature is, it's 20, so that'll be 293. 293.15 Kelvin, and the volume is 10 liters. Okay, calculator. So that comes out to 100.2448. Let's see, moles cancel, kelvins cancel, liters cancel, so it winds up to be a pressure. Kilopascals, and I need 3 sig figs, so to be exactly 100 kilopascals. Okay, next question. This is a little trickier one. It says the total pressure in the tank is 8 torr, and it says it's composed of 2 moles, let me write these, 2 moles of hydrogen. It has 3 moles of ammonia, 4 moles of CO2, and 5 moles of nitrogen. And they all exert a pressure of 800, and so what's the partial pressure of each one? So to do that, what you could do is add all of these up. So the 2, 3, that's 5, plus 4 is 9, plus 5 is 14. So the hydrogen contributes to 2 out of the 14 total moles, and ammonia contributes 3 out of the 14. Same thing with carbon dioxide and with nitrogen, so 14. So it contributes 2/14 of the total pressure. If the total pressure is 800, I can multiply that 2/14 by 800. Let me do that. Divided by 14, and that comes out to 114.28 torr. Rounding to 3 sig figs would be 114 torr. And I do the same thing for the rest of the questions. Same thing. Okay, good. At the end, maybe what you'd want to do is add the 4 numbers that you get, and hopefully come up to that 800 that they said you had originally. Okay, the last question. I've got a mixture of these gases, and what's the partial pressure of each gas, and what's the temperature? They just say what's the partial pressure of each gas. Another question, a good question would be, is what's the total pressure in the system? So what is the total pressure? And in the answer key I did that, but I didn't in the question. I'll just do one of them, and then you can do the rest. So if I want to know what the pressure of, say, nitrogen is, again, I'm not changing a pressure, volume, amount of moles, or temperature, so I'm going to use this ideal gas law, and I'm looking for a pressure. So the pressure is nRT divided by V. Moles of my nitrogen, I don't know that. Let me do that over here. Moles are mass over molar mass. The mass is 2.14 grams. The molar mass of nitrogen is 14.01, but there's 2 of them because it's N2. So it'll be 28.02 grams per mole. So let's divide those. 2.14 divided by 28.02. So it comes out to 0.07637 moles. So that goes here, 0.07637 moles times the universal gas constant, kilopascal liters per Kelvin mole. The temperature is 40. So 40 plus 273.15 would be 313.15. 13.15 Kelvin divided by the volume, it's 10 liters. So let's do that on the calculator. So that comes out to 19.88419. Let's see, moles cancel, liters cancel, kelvins cancel, wind up with kilopascals. round it to 3 sig figs, call it 19.9 kilopascals. And that's what they have there. So then you just need to do the same thing for hydrogen and for ammonia, and hopefully you get those numbers, and when you add them, hopefully you get that as your total. All right, hopefully that helps you with those gas questions.